pretty
I'm
tight.
on a pretty tight schedule, sorry everyone, but I really want to thank everyone for coming today, taking the time out of their day. I know we're all busy. And really, that's all I've got to say. Derek's gonna open everything up, but
Well, I have to say that Katie and Joanne have been handling all of the details, and I love having bowls of M&Ms. That is fantastic.
Send them down this way, would you?
I know, right? That's where you gotta choose your seat wisely.
Apparently so.
No hazelnuts though.
There you go. Well, and supposedly there's some fruit around it. So, as I mentioned before, I'm Derek, work with Ocean's Extension Service, and I'm not one of the presenters today, but Katie asked me to help a little bit in case there's any kind of facilitating or discussions or things that we need to do together. But a couple of things though, some thoughts. So I think that the whole point of today is really bringing us all together from all of our different backgrounds that all have an interest in this project. And we're here to learn together. We have some amazing researchers that are going to be giving some presentations and providing input. But at the same time, we're taking this information and trying to understand how that applies to this area of the Willamette River. And we all have different lenses, we all have different views, different values, different things that are important. And so we're taking this information and trying to learn together. And I think personally, as an outcome from today, what I would like to see is if there is kind of some next steps, if there is a smaller group or some kind of maybe it is this group, but that continues to meet and continues to wrestle with these issues and learn and try to come up with some solutions that are research-based, information-based. Is there anyone else that has some specific outcomes that they want to get out of this that would help, that you think it would be a successful day today, that you would like to share? Now, and Desiree has her baby boy. So
He
cute.
wants to participate.
Yes.
I'd like to understand what the approach is to getting data.
Okay.
How we're going to build a data set that is meaningful.
Okay. Approach getting data. Great. You're actually reminding me. Let's do a quick round of introductions, and I know that we have the sheet there, but I still think we need to start getting to know each other. And so as we do introductions, if you do have any outcomes or something that you would really like to get out of today, please go ahead and say that. If you don't, that's fine too. So if you say your name and maybe who you're representing or your particular interest in being here, that would be great. We'll let the researchers, they'll be introducing themselves as we talk. So can we start over here?
My name is Robert Meyer. I'm a building engineer. My interest is particular is I live in a flood pattern that is adversely impacted by rain. So I'm interested in all of this to see how it can help us.
Okay, thank you.
I'm Davey Robeck. I am a research student at the University of Portland.
All right, thanks.
My name is Josh Mahalam. I'm the Environment Policy Program Manager at the State Marine Board, and just looking for some data around this complex set of issues that we're currently dealing with.
Joanne Luciani, I'm a riverfront homeowner, and I'm also a member of Oregon River Safety and Preservation Alliance. And kind of the same as Josh, how are we going to address this issue from real data and science?
Hi, I'm Dr. Heather Dillon. I'm at the University of Portland. I work with Dr. Ford, who's going to be presenting in a moment. And I'm helping with the numerical methods analysis for some video work we're doing.
Laura Jackson, I am a board member of the Oregon State Board, and again, trying to get input and really listen to our constituents, residents of the state of Oregon, to get better information on which ultimately we'll be doing some decision making.
My name is Renee Morgan. I'm president of Calm Water Coalition, and practically everything that Laura said, I am also trying to do on the side of making policy. We're trying to gather information to help 1,200 people on the lower Willamette deal with new wake conditions that have just arisen in the last few years.
And I'm Jeff Reardon, state representative from District 48, which if you think went down into Happy Valley area, so I have no big river. Johnson Creek is kind of it. But we became involved with and learned a lot from a variety of people around this table about the impact for wave energy and the whole issues around the Newburgh pool. So very interested in that.
Ken Humberston, Clackamas County Commissioner. Interested in figuring out how we're going to square this circle. Obviously, some conflicting interests, homeowners, environmental issues, etc. on the one side, and obviously people in the boating industry on the other side that I know we're going to hear from at some point in time. So the more information I have, the easier it will be to help in making a decision that will work for people.
And I'm Darby Collins. I'm president of the Willamette Greenway Alliance, which is a bunch of homeowners and recreation folks up and down the Willamette. At that, we were working together to coordinate how we can look at all these issues, and whether it's erosion, recreation, the habitat, and really find solutions.
My name is John Haas. I'm a filmmaker and producer for television. I bought a house on the Willamette last year and didn't hear a single thing about it until last summer when my boathouse was damaged because of all the wave damage. My boat lived basically one side of the boat, the bolt sheared off and shoved my boat to the side of the boathouse. So that got me involved in this. I'm also,
when your ox gets gored.
Right. Well, you make the biggest investment of your life to buy a house on the river.
Yep.
And then you're seeing it being destroyed. I mean, this summer, the water was so low that part of my boathouse was sitting in the mud. And that wave energy was just slamming my boathouse into the mud all day long. So as a boat owner, I can't even use my boathouse for my boat because it's too dangerous for my boat. That's a real problem. I also look at what's going on in the river because it's close to the mouth of the Molalla River. All the little fish, and I'm also on the board of the Coastal Conservation Association Board and nationally, and just wonder what's going on with our endangered runs of salmon and skillet that run up that river when it looks like chocolate from this. So yeah, and I'm also potentially working with ORSPA on a video, just trying to tell the story of what we're going through.
I'm Travis Williams, Riverkeeper and Executive Director for Willamette Riverkeeper, and we've been working off and on the wake issue for 19 years, something like that, I have personally. And I have to say, I think we're at the point where it's kind of like Occam's razor. The issue is pretty obvious of what's happening and some of the impacts, and now we're kind of trying to backfill with study and data to legitimize, I think, what is really a pretty obvious situation. So and if we have to do that, that's fine. But I do think we're at the point where we need to make some real decisions about what types of craft belong where and on what sorts of water bodies. And I think the advent of this latest round of craft in the past just handful of years, we're in a different place. And so if we're not going to do something now, do we wait till the wakes are 5 feet, 6 feet, 7 feet? I mean, what's okay? So I know there's a lot of people here who agree with me, but that's where I'm coming from.
Hi, I'm Courtney Neron, and I am a new state representative for the Wilsonville to Hillsborough area. So I live very close to the actual river and along the Newburgh Pool section of the river in Wilsonville, and used to live on a property right on the river. And so this was an issue that I've been unaware of before being a legislator this year, and have learned so much. So part of what I am getting today is more information. Serving on the Natural Resources Ways and Means Committee with Representative Reardon, we address this issue, and wanting to make sure that I know who's who in terms of who I can go to for more information, and being new to policy making, learning that process, and I believe that the answers need to come from the experts and the people that are living this experience. So really kind of learning who has the information that we need to make good policy, and making sure that everybody's at the table to do so. Glad to be here. And I have my kids, Lucy and Owen, are with me today, so they are enjoying the journey to Corvallis with me. So, thank you for having us.
My name is Malia Masiva. I'm a senior legislative policy person with the Department of State Lands, and so as a through the legislature, one of the things that was talked about was getting data for the erosion. So we're here to, see that and get that as part of the next steps to go forward.
I'm Emma Hospice. I'm an intern with the city of Wilsonville, and I'm really just here to learn whatever you guys have to share.
And I'm Kerry Rappel with the City of Wilsonville too. I'm the Natural Resources Manager, so I've worked for many years in terms of protecting and restoring our riverbank areas within the city limits. I guess I'm looking to see like how other local jurisdictions can be involved with this effort too, and the awareness that they need to have, and the level of participation that would be helpful in terms of whatever comes from this.
Hi, I'm Katie Farrell, and I'm with Oregon River Safety and Preservation Alliance. I am also a homeowner on the Willamette River. I am very, very passionate about the Willamette, and really, more than anything, I want to know how are we going to restore our riverbanks once we solve this problem. And that's something we haven't even begun to talk about because we haven't solved the problem yet. So I'm really hoping at the end of today, we at least have some dialogue and have met other people that we can communicate with about this and move forward.
My name is Randy Wildman. I'm with the OSU Fisheries and Wildlife Department, and interested in the fish, native and non-native, in the Willamette system.
I'm John DeHoney. I'm sitting in for a board member of ORSPA. And I've lost some trees to the river this year, and a lot of erosion. And I'm in the wake zone, river wake zone, so we've got all the boulders in our area right now. And so I'm just getting into this because when I went in to put my down to the river and saw the trees that had fallen into the river, I had to pay to get some of them out of the way so I could do some work at the river. And so I'm a little disturbed about the fact that we're in the wake zone right now. And there's a lot more boaters that are in that zone, not just the wakeboard, because it's a free zone. And so I'm getting into the project now, kind of a newbie, and I'm anxious to hear what we can do about saving the shoreline.
I'm Greg Wilson. I'm an assistant professor in the College of Ocean and Atmospheric Sciences. My research is in sediment transport by waves. I'm interested in any kinds of problems like this that intersect with societal applications and research applications. Excited to learn more.
I'm Solomon Yim. I'm the civil engineering at Oregon State University. I've been working on fluid structure interaction problems for over 30 years. Wave impact on structures, and so sediment as well. I'll show some of the videos of what I have done in the past, and I understand the time is very short out of the schedule, and I just have a few slides just to demonstrate what we can do in terms of numerical modeling as well as experiments. I've done some experiments on both and wave effects, and also we'll do a lot of numerical simulations.
Just regarding, you know me, I'm better than Michael. I'm fundamentally interested on the experimentation of wave and wave structure interaction. And in this particular project, I am involved through the data gathering and understanding on how the processes are in most of the sections of the river, because my background is as a coastal engineer.
Can you say hello, Desiree?
So I apologize, I wouldn't usually bring a kid to a professional meeting, but my husband is out of town this week and he is sick. So not contagious unless you put his toys in your mouth. He's got a stomach bug, so he's with me today, unfortunately. But my name is Desiree Tullos. I'm a professor in biological and ecological engineering here at OSU. I've been here for 15 years. My background's in civil engineering. But what I do is water resources and river engineering. So I focus on things like reservoir operations and how to make reservoirs more sustainable, habitat restoration, that sort of thing. And in particular, I study hydraulics and fluid mechanics, but at the intersection with other things like fish or plants and how those relate to sediment transport. So that's what I'm going to do, is give the 30,000 foot view perspective of this idea of waves and its impact on bank erosion and on, in particular, out-migrating juvenile fish in the lower Willamette. So I don't know if we want to get started with that.
Yeah, so just real quick, so the bathroom and the restrooms are sort of in the corner on this floor, or, well, actually they're on every floor in the same place, but over in the corner, feel free, there's snacks in the back and drinks. We are going to be breaking around 11:15 or so-ish, whenever lunch is being brought in, because that'll be, a little bit noisy. So we have a few presentations. Desiree's going to go first so that she can take care of her baby. And yeah, thank you everyone for being here. Appreciate it.
All right, I'll be quick. I've got about 5 minutes worth of slides to introduce just the 30,000 foot view stuff. And so I'm going to start with this place. If the question is whether boat waves cause bank erosion, for example, boat wave record, bank erosion, that question's been answered a long time ago. And this is a study that USGS did on, and a literature review that they did include Pete Klingeman from this department, who's since retired. And anyway, the idea is that yes, absolutely, boat waves cause bank erosion. So that's not a question maybe that we need to answer. And one of the things that I've been working on this over time is appreciating that it's not just the biggest boat waves, but it's the combination of multiple things, but the big waves and the small waves. And so in this study, it was in Alaska, they showed, so this is their bank erosion pin. I guess it's kind of hard to see in the projector, but there's a lot of scour or erosion at the base of the bank, and that was associated with some of the smaller waves from boats passing through this reach. All right, so this is a little video that I use in my classes to illustrate how banks erode. And I thought this might be constructive to talk about to get into the physics of what happens. So this is your bank, your stream bank, and you've got this flow moving in the downstream direction. This is a cross section. And so what we have are two types of failures. We'll look at those in a little more detail, but this typically has some type of tension crack where soil expands and contracts because of clay, creates a crack. Then you've got rain, it comes down, and essentially it's like pushing the soil particles apart. It lubes things up, so then you can have these failure plains, these blocks of material that fail, they slide into the river, and then you have hydraulic erosion. So you have the downstream flow essentially dragging that fluid, that particle downstream. And then this sequence, this retrogressive sequence, essentially just continues to happen. So that material gets eroded, you have this bank steepening process happening again. It gets really steep, another tension crack, more infiltration, and this process sort of just continues to cycle. And feel free to ask questions as y'all have them. But this is sort of the standard model of what happens with stream banks and how they fail. And so when we think about like winter erosion, some of the questions have been raised about how is this erosion during the summer relative to what happens in the winter. In the winter, when you have high flows on the stream banks, so this is your bank profile, and this gray area is your water. Essentially, you've got something, the fluid is like dragging the particle downstream. So these three variables, this is applied shear stress, you don't need, the details aren't important, but the slope of the channel, and the depth of the water, and the weight of the water. So you imagine just a column of water just sort of dragging, creating this stress on the particle, it's going to move it in the downstream direction. So when we talk about hydraulic erosion in the winter, this is a key process. The other key process, illustrating the same thing you saw in that cartoon. You have an oversteepened bank, a bunch of material at the base, and this hydraulic erosion here, you've got a big pile, big column of water with a lot of force moving in the downstream direction. So that continues the cycle of oversteepening, erosion, and failure and erosion. The other key way we talk about stream banks failing is geotechnical erosion. I'm not going to go into too much detail on this, but it is important from a couple of perspectives. So if you take a small slice, a small cutaway of a stream bank, you have all these forces happening between individual grains. And so if the soil is really dry, it has essentially a suction, so that these particles are sort of held together. There's chemistry holding them together, chemical cohesion, but there's also cohesion just because the particles are so close together, and there's kind of like when, if you were to put a drop of water between your fingers and you slowly pull them apart, there's a little bit of tension. And that same thing happens between particles, and this, I'm setting this up to explain that how wet the soil is makes a huge difference. So in the winter, in the spring in particular, we're lowering when the river is drawing down, the banks are especially erosive. In the summer, they're really dry, so they tend to be stronger. So when we think, again, we'll come back to this winter versus summer. How wet the banks are is a really important part of the story in terms of how much and when banks fail. So I'm going to pull this all together here in just a second, but the third mechanism I want to talk about is this repetitive impact of numerous wakes. And so we've got hydraulic erosion of the toe, that material is sort of at the base of the bank. We've got the whole bank part failing. And then the third piece is this, essentially this sort of hammering of waves. And so it's a transfer. So if you imagine a wave moving across, it has mass because it's water, 62.4 pounds per cubic foot, and it has a velocity of some kind. And that transfer, it's like driving your car into a stream bank over and over again, right? It dislodges particles. It's transferring all of that energy that it has into the bank, because the bank, the wave crashes against the bank. So these are the key things that happen, the erosional processes. So you see both as those waves both crash into the bank and curl over in the shallow water, it actually ingrains or lifts, entrains or lifts particles up. It dislodges bank material that's crashing. It sort of essentially breaks the material apart. It washes some of that material off and then it transports it downstream. So we have all of these processes in a complex way happening. And I'm happy to share these slides if folks want to see them later, but sorry. Thanks. A lot of processes happening here, but essentially this is what's going on. You're crashing your car in the stream bank. It's creating these waves that lift particles up near the bed. You've also removing bank material by dislodging it, and then you've got these washing processes that remove the material. And then the other thing that's important, I think, to note, we are focusing in particular this conversation on these new wakeboarding boats because they produce really large wakes. But it's also the case that small boats can have an important impact. So, and this will get back to this sort of confounding factor that I'm about to introduce, or confactors that I want to introduce. But the idea is just because you have one wake boat that drives through a reach and nothing happens, you don't see a major catastrophic failure, doesn't mean that there's the table is not necessarily set for bank erosion, right? It's this cumulative effects of multiple boats. And so maybe what you'll see is 20 large boats move through a system and nothing happens, and then a small boat moves through and suddenly you see this plume develop, right? It's these layers upon layers of forces that summarily lead to bank erosion. So this is what I was trying to get at. It's in the winter, you've got toe erosion because you've got strong velocities moving downstream. You've got wet banks that are going to lead to the geotechnical failure. But in the summer, we're driving our car to the stream bank and creating this. And so this is some modeling that we've done on bank erosion, lateral erosion, and it's as you go across the channel. So like this is the river channel and this is the stream bank. And what I want to point out with this plot is just that you can have different types of failure in different zones, right? So you might have in one part of the bank, this is where we're simulating effects of shallow erosion versus these deep landslide types of failures. And you can get both those types of failures. Although in summer, you're not likely to get these big deep-seated failures because those are from geotechnical associated with saturated banks. So we can see different types of bank failure at different times of the year. And so to sort of summarize that, yes, if we think that, if the question is do boats, waves cause erosion, the answer is yes, we know that unequivocally. If the question is which boats at what speeds, the answer I think is complicated. So, and this is why. Whatever I'm trying to end us with. When I work on stream bank stability and stream bank restoration, the standard practice is use of factor of safety. And so the idea is that we have this sort of equilibrium or threshold condition. That you can, the stream bank itself has all of these forces that resist failure or resist erosion. And then there's all these other forces that drive failure. And so just like at the incipient point when the bank is starting to fail, then your resisting forces are equal to the driving forces. So like if this ratio is 1, then the bank is just barely stable. But as soon as those driving forces get a little stronger, this factor of safety drops below 1, and you have a bank failure. And so this is the theory on how bank erosion works. It's resisting versus driving forces, and as soon as these are larger than these, the bank fails. And so the idea is then, if we were to think about, again, this idea of, it's not about just one boat of one wake size going downstream. If you had 30 boats and they're all small, or 30 boats that are all large, it might be that 31st boat that really creates that next wake, because it's a function of how all of these processes are working together. And that one of them, that one of them is pushing these driving forces to be larger than the resistant forces. So it's a threshold process that which makes it really hard to say this boat of this speed is exactly going to lead to this type of erosion. And so that's I guess the key thing that I want to drive home, which is here my bullet. It's difficult to predict the effects of numerous wakes based on the effect of a single wake that's measured. And there's all these interacting things, right? So we have seasonal variability of the wake. So we can go out and measure, like McFarland did, and measure this boat of this speed and this size created this wake. And that's helpful, but it doesn't tell us how much erosion we can expect. Because we need to know things about like how much soil moisture there was, how much vegetation there are, what's the characteristic of the bank material, is it gravel or is it sand or is it clay? What is the profile of the bank? Is it really steep or is it pretty shallow as a slope? Do we have a bunch of weight, or like buildings or anything else? And then these wakes interacting. I mean, it's just, and I don't mean to be a sort of standard science response of it depends, but it depends. We can't, it's really hard to say, we're gonna go measure a single boat and say this leads to this much erosion, because its environmental complexity is there. So I think we need to be careful about, McFarland study is great, and I have no complaints about it in terms of being able to predict the wake size, but transferring that wake size to the amount of erosion is the problem. That's the difficult part, is we got a wake of 3 feet, how much erosion it produces is a function of environmental variability, all these factors, which makes it challenging. And one thing that I know has been talked about a little bit, but I want to point out is that there are fish in the lower part of the Willamette that are using these margin habitats. There's been a few studies, and Randy can obviously speak to this as well, but they use these nearshore habitats. And there's been work by folks at ODFW and Bureau of Environmental Services in Portland, studying where these fish are. They use the last sort of 10% roughly as they move out of the system, so the margins where these waves are crashing on the shore. And they peak in the system, the Chinook, False Chinook, Steelhead, and Coho apparently peak between May and June. So that's the early part of the summer when people are out there in the wakeboards, but they also are found throughout the entire summer. So we need to be careful in thinking about what types of solutions, if we permit certain boats versus other boats, and what those implications might be for these fish. And just for context, this is from the recovery plan for the Upper Willamette, Chinook, and Steelhead. And one of the strategies for helping to recover these species is to reduce or eliminate sources of mortality. And they explicitly call out stranding of juveniles due to ship wakes in the estuary. And so we're not in the estuary, right, because we're above Willamette Falls, but it draws attention to the fact that these fish probably are not used to the sloshing wake as they're trying to move out of the system, right? That they can, in the lower parts of the system, they're getting stranded, potentially on beaches. I don't know if that's occurring. I haven't been out there and studied these fish myself, but that this has been identified as an issue in the lower Willamette. So that's my crash course at 5 minutes with a screaming baby in my head. Thank you. Do y'all have questions?
How do you get a copy of that?
I can give them to whoever, maybe. Yeah, I do have a copy of them actually already. I mean, I emailed them to you.
Yes.
So, or you can shoot me an email, and we'll be home in a couple hours. I'll type it in to you too.
Okay, thanks.
Can you send this to everybody?
Yeah.
Absolutely,
Yeah, no problem. Yes, sir.
Given the number of variables, is there a way you can boil this down to a clear enough message that says that big wake boats are causing more damage and should be banned forever?
There you go, that's the fundamental question.
I think Travis made a point earlier that I think is worthwhile, in the sense that we can spend a lot of time studying this problem and get you an approximate error, estimate of the boat size it's going to lead to amount of erosion, some regression relationships, or some hydraulic models that are actually process-based, but they're going to have a lot of error in them, and they're not going to be able to promise you that there won't be any erosion, right? So I think I don't know that this is necessarily a question of scientific uncertainty. I think if you really want to prevent erosion in that system due to boat wakes, there shouldn't be boat wakes that are, that large in the system. Especially when we think about the fish, right? Because we don't know what exactly the impacts are on them and how to predict whether there's going to be direct mortality of them getting slammed against the stream
If
banks.
I were on the other side of the table, and I'm in the boating industry.
Right.
The degree of uncertainty, I think it makes us kind of vulnerable here from when we're trying to set policy.
Yep.
So I'm eager to learn more here today, but it's really kind of an uncomfortable position.
I can definitely understand that. And, yeah, I'm trying not to wade too far on the policy side and stay on the science side of things. But I understand that scientific uncertainty makes it difficult to set a policy. I would say that in the interest of being most confident in the outcomes, I think not having large wakes in that system is likely to be most beneficial from a bank erosion and protection of banks, stream banks and habitat.
I think one of the things that was most compelling argument was thinking of large waves going across docks, knocking small children off into the river. That seemed like a pretty clear cause-effect sort of thing that
Right.
as a basis for policy. This is kind of so-off.
Well, if you imagine the same analogy, it's if your child is 1 year old versus the child is 5 years old. If it's 5 years old, maybe they can stay on the dock. If they're 1 year old, maybe they can't. So essentially, we're kind of doing the same thing, saying, well, maybe we're okay with the uncertainty of a large boat creating, or large wake creating. Now the analogy's falling apart, but the idea that there's still uncertainty in every decision that we're making. That and decisions can be made under uncertainty. We just need to be clear about what our sort of justification for those decisions are. So I'm being intentionally a little vague because I'm trying not to get too far on the policy side of
And I
things.
don't mean to sound critical at all
Yeah.
of the work. I'm just trying to point out the
Yep.
I'm going to use the word
the obvious.
Right. I definitely understand that, and the recreational interests are just as valid as anyone else's. Although one could argue that they have other places to go recreate, and the lower salmon don't really have other places to go migrate out to the ocean.
I just had a question in regards to that factor of safety and
Yeah.
balancing. So, we've tried to use bioengineering as much as we can for
Yeah.
slope stability and slope restoration. I was just wondering, are you aware of any studies that are actively looking at the application of bioengineering and how it takes into account, the driving forces and resistant forces?
Yeah, totally. I'm happy to point you to all that literature. It's something
Okay.
I spent a lot of time on. The Corps of Engineers have probably developed the science of that the most. I've developed it the most. But there's really great resources that I'm happy to point you to if you shoot me an email.
Okay.
Yeah, so even like Core 5, but yeah, all the different strategies they have, you can directly plug into this type of approach. Yeah.
Hey, thanks